So in this section we're going to talk about graphing in polar coordinates, and first thing I want to talk about is symmetry with polar coordinates. To be symmetric about the x-axis, if the point r theta is on the graph, then the point r minus theta must be on the graph. So I'm going to show you an example of that. Also the point minus r pi minus theta could be on the graph as well. But I'm going to show you a graph that we can see is symmetric with respect to the x-axis, and you can see that r theta and r minus theta are actually on the graph. So here's an example here of a cardioid, and notice here's r theta on the graph, and down here we have r minus theta on the graph. So there's your x-axis symmetry. Now, you could also look for graphs that have this relationship too, but I didn't look for that one. Didn't do an example of that one. I did on the next one though. Symmetry about the y-axis. Well, for symmetry about the y-axis, if the point r theta is on the graph, then either minus r minus theta is on the graph, or r pi minus theta is on the graph. Now, I did this example for the y-axis symmetry. So if you look here, here's r equal to sine theta. It's obviously symmetric with the y-axis. And you can see here I have r and then theta is pi over 6. And if you think about what is r and pi minus pi over 6, well, pi minus pi over 6 is 5 pi over 6, and that point is right there. So there you have r theta, and you have r pi minus theta. So that's y-axis symmetry. Now, symmetry about the origin, for that to hold true, when r theta is on the graph, you either have to have minus r theta on the graph or minus r theta plus pi on the graph. Now, I went with just the simple case here of a circle to show you this one. Now, the circle has origin symmetry. Actually, it has all three symmetries, but it has origin symmetry because when r theta is on the graph, then minus r theta is on the graph. So notice here, I took just the simple points here. This is 2 pi over 2, and so if 2 pi over 2 is on the graph, then minus 2 pi over 2 must be on the graph. And then here we have this point would be 3 pi over 2, because this would be 2, and then you're going over 3 pi over 2 to get there. But if you go minus 3 pi over 2, you're actually back over here where this point is. So there's minus 3 pi over 2 there. So there you can see it satisfies that if r theta is on the graph, then minus r theta is also on the graph. Okay, so we learned earlier how to find the slope of a graph in Cartesian coordinates. Now let's talk about how to find the slope of a graph in polar coordinates. Now we're going to talk about the slope of a curve in polar coordinates as r equals f of theta. And we're going to use the dy over dx notation rather than r prime notation. So let's consider these parametric equations here. So let's suppose that x is r cosine theta. So we can say, well, r is f of theta. So like I said here, we're going to say r is f of theta. So r is f of theta, and so that would x would equal f of theta cosine theta. And if we say y equals r sine theta, which of course, you know, y does equal r sine theta in polar coordinates, then that would be, we can say that's f of theta sine theta. Now, we can actually write dy over x like this. Dy over d theta over dx over d theta is actually equivalent to dy over dx. Okay, now we can find dy d theta from this, and so dy d theta would be the derivative of f of theta sine theta and using the product rule, that would be f prime theta sine theta, and then plus f of theta cosine theta. And then similarly we can get dx d theta using the product rule, so that would be f prime theta cosine theta minus f of theta sine theta, again just using the product rule. Okay, so now since we know that dy over dx is dy over d theta over dx over d theta, we can put dy over d theta on top, put dx over d theta on bottom, and that will give us the polar slope formula, and where f prime of theta is the derivative of f with respect to theta. And again, we got to make sure, as long as the denominator dx over d theta is not 0, we'll be able to get this slope formula. Okay, let's find the slope of this graph at theta equal pi over 4. So using this formula up here, f of theta, instead of r, we'll say f of theta. F of theta would be 1 plus cosine theta. So the derivative of that would be minus sine theta. So remember that. The derivative of this with respect to theta is minus sine theta. So plugging it in this formula, we get minus sine theta times sine theta, and then plus f of theta. So that would be 1 plus cosine theta times cosine theta. So that's the numerator. The denominator would be f prime of theta, so it's minus sine theta times cosine theta, minus f of theta, 1 plus cosine theta times sine theta. Well, then if we do some algebra here, we get minus sine squared theta plus cosine squared theta. And on the bottom, we get minus sine theta cosine theta. And then if we distribute the minus and the sine theta, we get minus sine theta cosine theta minus, let's see, I think I left out one here. Okay, I had to make a correction there. You probably didn't realize it since there was just a short break. But basically, I'm going to start this one again and just kind of go over the first part kind of quickly. So the derivative of this is, of course, minus sine theta. So you have minus sine theta times sine theta, 1 plus cosine theta from the formula. And then on the bottom, you have minus sine theta cosine theta minus 1 plus cosine theta sine theta. And then when you multiply, you get minus sine squared cosine theta plus cosine squared theta. And then on the bottom, you have minus sine theta cosine theta here. And then when you distribute the minus and the sine theta through, you actually get minus sine theta minus cosine theta sine theta. Now, the top is cosine theta plus cosine squared theta minus sine squared theta. The bottom is actually minus sine theta, and then you have two of these minus sine theta cosine theta. So we have minus sine theta minus 2 cosine theta sine theta. Now, cosine squared theta minus sine squared theta can be written as cosine 2 theta, so I simplified that there. And then I took the minus out and I put it in front here of the, well, I factored a minus sine theta out of here, and that gave me a minus sine theta here, and it left me with 1 plus 2 cosine theta on the inside. And then I took that minus and I just put it in front of the fraction. And so now I need to evaluate this at pi over 4. So I have minus cosine pi over 4 plus cosine pi over 2. So the numerator is pretty easy. This is square root of 2 over square root of 2, because the cosine of pi over 2 is 0. Well, at the bottom I have sine of pi over 4, which is square root of 2 over square root of 2. And since the top is just square root of 2 over 2, and the bottom has a factor of square root of 2 over 2, those just cancel and give me 1 in the numerator. And then I still have the minus here, so I have minus there. And then on the bottom, 1 plus 2 cosine of pi over 4 is actually 1 plus 2 square root of 2 over 2. And actually you can cancel the 2's here, and you get minus 1 over 1 plus square root of 2. So I just didn't do that last step, but minus 1 over 1 plus square root of 2 is your final answer. And so that's the slope of the graph of that graph at theta equal pi over 4. Now the next one is the graph is 2 sine theta and I want the slope at pi over 6. So the derivative of 2 sine theta is actually 2 cosine theta. So using the formula, f prime would be 2 cosine theta sine theta, and then f of theta cosine theta would be 2 sine theta cosine theta. And then on the bottom I would have f prime times cosine theta, so I have 2 cosine times cosine, and then minus f of theta sine theta, so that's minus 2 sine theta sine theta. Well, the top is just 2 cosine sine plus 2 cosine sine, so that's 4 cosine sine. And on the bottom, I can actually factor out the 2, and then this is cosine squared minus sine squared. So, and then I can actually cancel the 2 into the 4 here and get 2 sine theta cosine theta. And the bottom is cosine theta minus sine, cosine squared theta minus sine squared theta. Well, finally, this can be written as sine of 2 theta, and this can be written as cosine of 2 theta. And as you can see, I used x just to have it there instead of theta. So actually, that's cosine 2 theta, sine 2 theta over cosine 2 theta, and that's actually going to be tangent of 2 theta. So now what you have to do is put theta in here, which is pi over 6, and then you have to multiply it by 2, and 2 times pi over 6 is pi over 3. And so tangent of pi over 3 is actually square root of 3. So the slope of that graph is square root of 3. So that completes this portion of this video. On the next video, I'm going to talk to you about graphing polar curves using a chart. So be sure and look at the next video for the graphing portion.